In this section, we're going to look at a parabola and ellipse. So these are very cursory notes, just filling in some important information from Chapter 9. First, we'll look at a parabola, which I know we looked at before, but we're going to give it a definition consistent with conics. And a parabola consists of the set of points that are the same distance and we say that distance is d from a line which is called the directrix. And a point not on the line which is called the focus. This definition makes a little bit more sense if we have an illustration. So if I was to draw a line, that would be my directrix. And then I can draw a point up here, which is the focus. And let's change the color of that one. Then my parabola will be all the points such that any given point on the parabola, the distance from the focus to the directrix will be the same. Those will both be a distance of d. I can see the same thing happens with the vertex. No matter what point I'm looking at on my parabola, it's the same distance from that point to the focus and that point to the directrix. We're going to focus on two different versions of the equation for a parabola. The first one is probably the one you're more familiar with, where we have f of x equals ax squared plus bx plus c. And that's when we get a parabola that's either upward facing or downward facing. Or we can have g of y equals ay squared plus by plus c. And that gives us a parabola that's either opening right or a parabola that opens left. In either case, well, with f of x, our vertex is at negative b over 2a, comma, f of negative b over 2a. And then with our g of y, our vertex would be at g of negative b over 2a or negative b over 2a. The important thing to realize is whatever your input is, the value of that variable for the vertex is negative b over 2a. And then we can just plug it into our equation to solve for the other variable. Let's look at version 2 though, because this one's new and important to make sure that you understand. We can also write our parabolic equations as either f of x equals a times x minus h squared plus k, where our vertex is h comma k, or we can write it as g of y equals b times y minus k squared plus h, where again our vertex is h comma k. Those are the basics for a parabola: the definition, graphically, and then equation. So let's look at an example. We want to graph the equation negative y squared plus 2x plus 2y plus 5 equals 0. We want to make sure that we find and label its vertex. Try this on your own first, and then resume the video when you're ready to check your solution.